On this chapter, we're going to prove the identity. And we've done these topics before in previous videos. So if you want to check those out first to get a little comfortable with it. But this one includes more identities that we need to use in order to prove the identity, right? Um, the rule of thumb that I teach in my class and I teach to you guys is that always go from the hardest part to the simplest part, right? So if I look at the first example, you have this two fractions being added and you have equal to 0. It's very hard to prove that from 0 you can get all of that, right? So it's usually the rule of thumb is go for the side that has most complex things going on. Okay, in this case, the left side. So let's start with the left side. Well, I have a fraction. My intuition should say, okay, find a common denominator. That might not work, right? Like, it's not always a very straightforward um, approach, but that's what my intuition say. Now, before I even find a common denominator, I like to work with sines and cosines instead of tangents and cotangent. Why is that? Well, there's more identities related to sine and cosine than there is for tangent and cotangent. So, in my opinion, I would attack this problem by making tangent and cotangent into sines and cosines. So, how would that look like? Well, it's going to be 1 plus sine over cosine. That's the first numerator. 1 minus sine over cosine. Okay? Plus, and then 1 plus cosine over sine over 1 minus oops, let me put it a little bit higher. Cosine over sine. Okay? Now I will find the common denominator between each individual fraction before I try to find the big one. Okay? So here 1 plus sine over cosine, the common denominator is cosine. Here is sine, and this one is cosine, and here's sine. So again, on the top you have cosine over cosine, which is 1. Sine over cosine over cosine over cosine again minus sine over cosine plus the same thing for this fraction. It's going to be sine over sine cosine over sine over sine over sine minus cosine over sine. Okay. Now we put them together. That's the purpose of finding the common denominator. So cosine plus sine over cosine. That's the top. This is that top numerator. And then cosine minus sine over cosine and plus sine plus cosine over sine and then sine minus cosine over sine. Yeah, and then whenever you have a fraction divided by another fraction, you multiply by the reciprocal of the fraction in the denominator. So cosine plus sine over cosine times the reciprocal of this denominator, which is going to be cosine over cosine minus sine And the same thing for the next fraction. So sine plus cosine over sine, and then sine over sine minus cosine. Okay? Now, I usually tell my students to use the commutative property of multiplication. Okay? So take this denominator and flip it with this denominator. So I'm going to rewrite it again. And the reason I do that is because cosine over cosine is just equal to 1. So I can get rid of that. So now I'm going to have cosine of theta plus sine of theta over cosine of theta minus sine of theta, and then plus sine of theta plus cosine of theta over sine of theta minus cosine of theta. Now, this is the next trick, okay? Notice that the denominators are almost the same, but the signs are inverted. So I'm going to multiply on the right one by -1 over -1, okay? And by doing that, I have to distribute this -1 onto both, okay? So on the left side, I leave it alone. Now I'm going to put a plus here. -1 times sine is negative sine. -1 times cosine is negative cosine. -1 times sine is negative sine, and -1 times negative cosine is positive cosine. So I'll have cosine minus sine. Now that I have a common denominator, I can put them together. So now you have cosine of theta plus sine of theta minus sine of theta minus cosine of theta over cosine of theta minus sine of theta. Now you have cosine minus cosine is 0, sine minus sine is 0. So you have 0 over cosine theta minus sine of theta, which is equal to 0. And that would be the answer. Now, you might wonder, man, is there an easier way to get to the answer? There probably is. Again, the beauty about this topic is that you can be creative about it. You can go through other routes and find the solution faster, or even it will take or longer. It depends on what your approach is. This was my approach. This is what I feel that I would get the answer most effectively. It not necessarily means it's going to be the fastest way. Okay, so let's go to the next example. So it says secant of 2 theta equals secant squared of theta over 2 minus secant squared of theta. Again, very similar to the first approach, I'm going to convert the secants into cosine. So I'm going to use the right side first. I'm going to prove it to be the left side. So you get secant squared is 1 over cosine square of theta. And then 2 minus 1 over cosine square of theta. Now, I'm going to leave this fraction alone. On the bottom, though, I'm going to find a common denominator. So 2 over 1 times cosine squared over cosine squared minus 1 over cosine squared. Okay, continue over here. So cosine squared of theta over So it's going to be 2 cosine square of theta minus 1 over cosine squared. Okay? Now, you can change this by using the identity now or later, it doesn't matter the order, but we're going to change it eventually. For now, I'm just going to multiply by the reciprocal of the denominator, so 1 over cosine squared of theta times cosine square of theta over 2 cosine square of theta minus 1. I'm going to use the commutative law again. I'm going to flip these two. So it's going to be cosine square of theta over cosine square of theta times 1 over 2 cosine square of theta minus 1. Okay? And that's equal, this is equal to 1. This is equal to 1 over. Now 2 cosine square of theta minus 1 is cosine of 2 theta. Okay? And then 1 of cosine of 2 theta is secant of 2 theta. And that will be your answer. So that one was a little bit faster. Now this one is hard to tell like which side to begin with. Now, given my experience, I think the best side will be the left side because of the cosine of u minus v. Okay? So what is cosine of u minus v by identity? It's cosine of u, cosine of v, plus sine of u, sine of v, over cosine of u, sine of v. Now if you divide these two terms together, so cosine of u, cosine of v, divided by cosine of u, sine of v, plus sine of u, sine of v, over cosine of u, sine of v. Well, notice what happens. Cosine of v over cosine of u is 1, so you're left with cosine of v over sine of v, plus sine of v over sine of v is 1, so you're left with sine of u over cosine of u. Now cosine of v over sine of v is cotangent of v, and sine of u over cosine of u is tangent of u. And that will be your answer for that. Okay? If you like the video, leave any comments below. If you have any questions, you might as well ask me. I'm usually very fast responding questions in YouTube. Or ask me in class if you're in my class. Thank you. Have a good day.